Welcome to our video on translating sentences into equations. Before we translated sentences into expressions, now we're translating them into equations. And you'll see that it's the same darn thing, only now we have an equal sign in there somewhere. We're going to look at how to solve some of them and then translate them. So let's first look at solving integer problems. The basic, simplest ones, right, where all of our numbers are whole numbers. Just like we have certain words and phrases that always mean addition, certain words and phrases that always mean subtraction, and ones that mean multiplication, ones that mean division, there are certain words or phrases that always translate into equals. Obviously, when you see the word equals, but is the biggie. Whenever you say is, that's almost always equals. And then is equal to, amounts to, represents. And in fact, a lot of times when you get other versions of is, so was, were, has, all those types of things will oftentimes translate straight into an equals symbol. So keep that in mind. Okay, translate 5 less than a number is 13. Well, here's one phrase, 5 less than a number is 13. So there's my equal sign. I know that this thing is going to equal this thing. 13, that's pretty easy, right? We just translate that to 13. 5 less than a number, that's where you got to think, okay, is it 5 minus n or is it n minus 5? And if you have the kind of instinct to think it's 5 minus n, well, really, in either case, whether you know for sure that it's n minus 5 or you might think it might be 5 minus n, plug in some numbers and make sure it works. And I don't mean plug in numbers to solve it. Just think of 5 minus n and then plug in a number for n and see if the number you get is actually, according to the English, 5 less than that number. Right? Because n is that number. N is the unknown. And if you do 5 minus n, let n be 2. 5 minus 2 is 3. Is 3 really 5 less than the number? And you go, no, that doesn't work, right? So I screwed up. I went in the wrong way. It's got to be n minus 5. So you do n minus 5 equals 13, add 5 to both sides, you get an answer of 18. Simple, easy, right? Okay, when we talk about integers, we know that the integers are all whole numbers, including 0 and the negatives. Even integers, of course, are the ones that are divisible by 2. Odd integers are the ones that are not divisible by 2. And by the way, 0 is considered even because 0 divided by 2 is still 0, right? You get an answer that doesn't have a remainder. And basically, if you look at the numbers, they always alternate. Even, odd, even for 0, odd, even, even. Okay? All right. That's going to help you because there are a lot of questions you come across where they say, the sum of 3 consecutive integers, the sum of 3 consecutive even integers, the sum of 2 consecutive odd integers. You need to know what the heck all that means. Well, for instance, we know what even and odd means, but what about consecutive? Consecutive just means they're in a row. They're next to each other in the list. So consecutive integers could be 1, 2, 3, 5, 6, 7, 11, 12, 13, negative 8, negative 7, negative 6, negative 9, negative 8, negative 7, negative 3, negative 2, negative 1, negative 1, 0, 1. You can see we can go on and on forever. But basically, they're going to be of the pattern n, something we don't know what it is. The next number is going to be n plus 1. The next number is going to be n plus 2, right? Because if we did 1, 2, 3, well, 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3, right? For 11, 12, and 13, n is 11. 11 plus 1 is 12. 11 plus 2 is 13. If n is negative 8 plus 1 is negative 7. Negative 8 plus 2 is negative 6. You see how that works? Okay, so that's the first thing to figure out. And then when you get consecutive even, they're still in a list, but they alternate, right, because you're only picking up the evens. So 2, 4, 6, 8, those are consecutive evens. Negative 2, negative 4, negative 6, although we normally go from smallest to big, so we would do negative 6, negative 4, negative 2. So on and so forth, consecutive odds, 1, 3, 5, 7, blah, 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 blah. Here's some examples, and you can see that for both of them, the pattern is still the same. You're adding 2 each time because you have to skip that other integer, right? So if you're doing consecutive evens, you got to skip those odds that are in between them. And if you're doing consecutive odds, you got to skip the evens that are in between them. So it's always going to be n, n plus 2, n plus 4, and so on and so forth. Don't bother wasting brain power memorizing these patterns. When they talk about consecutive even integers, just write 3 even integers, let n be the first one, and then figure out, okay, how do I represent that second number in terms of n? So even if you chose 24, 26, 28, you go, okay, n equals 24. All right, 26 is 2 more than that one, so that's just n plus 2. Okay, that's 4 bigger, so that's n plus 4. And there's your pattern. You don't have to memorize it. You can recreate it with a simple example each time. Okay, here's another example. The difference between 4 times the smaller number and 2 is 2 more than twice the larger number. Whew, there's a lot going on, right? The sum of two numbers is 16, and then the difference between 4 times the smaller and 2 is 2 more than twice the larger. Wow, you just got to take it in pieces. But they did give you a bunch of information. We know that the sum of two numbers is 16, so we know these two numbers, x and y, when you add them together is 16. We also know the difference between 4 times the smaller number and 2 is 2 more than twice the larger number. Okay, so let's take this in pieces. The difference between 4 times the smaller number and 2. Well, we're looking at the difference between two things. What are those two things? 4 times the smaller number and 2. So 4 times the smaller number and 2, and we're looking at the difference between those, is 2 more than, so something plus 2, right, 2 more than, twice the larger number. So 2 times the larger number. We'll just give it a different variable for now, but we can actually put those two things in terms of the same variable because they gave us this idea here that the sum of the two numbers is 16. So we know n plus m equals 16. So m equals 16 minus n. We can do that substitution, and all of a sudden 4n minus 2 equals 2 times 16 minus n plus 2, in parentheses, right? Because it's 2 times m, and if m equals all of that, then all of that stuff has to get multiplied by 2. And now it's just a matter of solving it. So we did our substitution, we do our distribution, right? 2 times all this stuff. Then we combine like terms, nothing to combine over here. We isolate our variable, we keep it positive, so we're going to move the 2 over here, get 6 of them. Going to move this negative 2 over here. Right, so we have to add it, get 36, 6n equals 36, divide both sides by 6, n equals 6, plug that back into the equation of 16 minus n to figure out the other number, and we get 10. Smaller number is 6, larger number is 10. Okay, simple, easy. How about translating a sentence into an equation and solving? Well, didn't we just do that? We absolutely did, but now we can do it again with kind of a more word problem-y feel. Instead of just this number and that number, we can actually have some context. A wallpaper hanger charges a fee of $25 plus $12 for each roll of wallpaper used in a room. If the total charge for hanging wallpaper is $97, how many rolls of wallpaper were used? Well, we know that their total fee was $97. And we also know their total fee is going to be $25 plus $12 times how many rolls we have. We don't know how many that is. That's our unknown, right? Because what's the question? How many rolls of paper were used? That's our unknown. That's our x. So the first thing you do is figure out what your question is, assign it a variable. Now we go back and translate. 25 plus 12 for each roll, and the roll is what we're looking for. That's our variable, and that equals $97. And this should be pretty simple, right? Subtract 25 and divide by 12. Subtract 25, divide by 12, and you can see that we used 6 rolls of wallpaper. I, of course, used n here because the book keeps using n, but it doesn't matter if you use x or n. It's all the same thing. All right, that's all we have for this one.